Good morning, partners and colleagues. I hope everyone has been keeping safe, healthy, and well. I am Ivan Christian Limbuco, Philippines Country Co-Lead for the Clean Energy Investment Accelerator, or CEIA. And it is my pleasure to welcome you all to the CEIA Regional Capacity Building event, Clean Heat Pathways to Decarbonize the Industrial Sector in Southeast Asia. The whole CEIA team would like to thank everyone, especially the attendees from Vietnam, Indonesia, the Philippines, and other parts of the world for taking the time to be with us this morning. So we have prepared an exciting session for everyone as seen on your screens. So this is a snapshot of the program for the next 2 hours, and we look forward to everyone actively participating during the panel discussion and the question and answer portion. As you can see from your screens, kindly use the Q&A box found on the bottom of your screen or the chat box to send any comments, any questions, and reactions to the presentations and to the speakers at any point during the program. So before I proceed, just a quick introduction to the CEIA. So the Clean Energy Investment Accelerator, or CEIA, is a public-private partnership initiative that addresses barriers to clean energy deployment in the commercial and industrial sectors in emerging markets, including the Philippines, Vietnam, and Indonesia. The CEIA is jointly led by the World Resources Institute, or WRI, the Alcho Partners, and the U.S. National Renewable Energy Laboratory, or NREL. CEIA partners with large energy purchasers to send a strong demand signal for clean energy, collaborates with governments to strengthen policy frameworks, and supports the implementation of innovative procurement approaches to grow clean energy project pipelines. So CEIA acts as a bridge, translating international commitments into on-the-ground market transformation. In response to requests from private sector stakeholders seeking to implement their clean energy and net zero emission goals, CEIA has been expanding its efforts to support the exploration and deployment of clean heat technologies in Southeast Asia. So, while we acknowledge that measures such as deployment of renewable energy initiatives and implementation of sustainability practices are the common procedures for industrial decarbonization, we are also aware that innovative solutions such as clean heat deployment is imperative in contributing to these decarbonization efforts, as seen in, as reflected in these two documents, in these two publications, which one of our speakers, Alni, will be diving deeper into her presentation. So for aiming for the momentum of decarbonization, the aim for this Clean Heat initiative is to foster collaboration between these three entities, the government, the solution providers, and the corporates as well. It is important to foster these collaborations to jointly identify opportunities, identifying the barriers and how to overcome them in terms of deploying clean heat in their facilities. And then the objective as well of this focus group discussion is to gain insights and gain knowledge and best practices as well from representatives from the region, and how we are able to really apply these practices and how we can contribute to the success of clean heat deployment in Southeast Asia as well. And also, in addition, any barriers that cannot be addressed by the private sector alone will be brought to the attention of the policymakers with the aim of addressing them through regulatory and policy intervention. So as we move forward with this program, we in this slide, you can just see a snapshot of the steps that the CEIA team is taking through a phased approach in order to achieve the objectives that we have set. So as you can see here, we have started with a focus group discussion, and then a knowledge product as well we have developed, and this will also be presented later during the program. And then we are now here in the step of conducting capacity building activities, as well as policy engagement. And in future phases, we will be depending on the needs determined throughout the previous phases. This will include further training and workshops on clean heat feasibility assessment tools, technical assistance to corporates, support in deployment and implementation, as well as the development of additional knowledge products in the future. So we're very excited to share this work and these steps with all of you. And for this event, so here are just the objectives of this regional capacity building event. So the CEIA Clean Heat Regional Knowledge Product is disseminated to stakeholders from Vietnam, Indonesia, and the Philippines, and also feedback is received. CEIA corporate stakeholders' awareness and understanding are increased and leveraged to aid businesses in assessing the benefits and advancing the shift towards these technologies in support of corporate decarbonization efforts. And lastly, CEIA capacity is built related to clean heat technology. So without further ado, we could now proceed to the next portion of the program, which is the presentation of insights from the CEIA Regional Clean Heat Knowledge Product, to be presented by Ms. Alni Demoral, energy analyst for Alsho Partners and the technical working group of Clean Heat, the lead for CEIA. So Ms. Alni Demoral has over 6 years of experience in the energy sector, working as a process engineer and as an energy policy analyst. So her key areas of expertise include energy systems modeling and performing techno-economic assessments on clean and emerging technologies. Alni holds a BS in Chemical Engineering from the Technological Institute of the Philippines and a master's degree in Energy Engineering from the University of the Philippines. Everyone, please give a round of applause for Ms. Alni Demoral. Alni, the floor is yours.
Thank you, Ivan. And good morning, everyone. Thank you for joining us in today's event. And we are very much delighted to have you here with us. So I will be sharing some insights from our regional knowledge product on clean heat. So can I have the next slide, please? So as Ivan mentioned earlier, the CEIA is an initiative aimed at engaging commercial and industrial companies to mobilize the investment on clean energy project through innovative clean procurement models and advocating for a stronger policy framework, particularly on emerging markets like the Philippines, Indonesia, and Vietnam. Our focus is in supporting corporates in achieving their renewable and sustainable goals and targets. And yeah, the reason why CEIA delved into the topic of clean heat is that in previous CEIA events, corporates has emphasized the importance of utilizing clean heat to achieve their sustainability goals. And these companies recognize that reducing greenhouse gas emissions and transitioning to clean energy sources is crucial for advancing global efforts to combat climate change. So that's why we are thrilled to see these strong desires from companies to reduce their carbon footprint, and the interest of this company is evident by having you join this webinar today. For we believe that it will be everyone's effort to achieve or everyone's effort is required to achieve the climate targets, and corporates like you can play a significant roles into driving this emission reduction. So that's just for the background on why we are actually doing this. Next slide, please. Yeah. So the insights that we are going to present in this material is based on the knowledge product that was developed by the regional CEIA working group on clean heat. It is called Clean Heat Pathways to Decarbonize the Industrial Sector in Southeast Asia, Private Sector Insights and Case Study from Philippines, Vietnam, and Indonesia. You can scan the QR code here in this slide or visit cleanenergyinvestment.org/resources to download our report. So please do that. Yeah, so on to the main highlights of the report. You've also seen these slides from the context setting. So the just a few contexts on this one. The recently published IPCC report on global warming of 1.5 emphasized that clean heat technologies will play a critical role in achieving our goals for the Paris Agreement. And this similar insight has been echoed in the region into this report called Seven ASEAN Energy Outlook, which also notes that the importance of clean heat technologies in reducing emissions for the industrial sector in Southeast Asia. Next slide, please. So for more context, the adoption of clean heating technologies holds significant importance in our country. The Philippines, Indonesia, and Vietnam are experiencing rapid economic growth and industrial advancement, resulting in a heightened need for process heating. But unfortunately, conventional fossil-driven heating methods are still widely used. And although it may seem reliable in operations, it could still present some environmental concerns. For example, in Vietnam, according to the survey, out of the total of 2023 boilers surveyed, coal boilers accounted for the largest proportion of 34%, followed by biomass at 23%, diesel oil at 17%, and the rest is other fuels. We had found that, no, not yet. We had found that in Philippines, Indonesia, and Vietnam, electricity is primarily used in powering up machinery and equipment, while fossil fuels like coal, oil, and natural gas dominate the heating. Heavy industries like iron and steel, cement, glass production heavily relied on coal due to high operating temperatures of these processes, while low-rank coal is popular in lighter industries. Good thing is that in biomass, in food processing, biomass has been widely used in Philippines and Vietnam due to their availability and cost effectiveness in comparison to conventional fuels. Meanwhile, Indonesia's chemical sector uses natural gas for process heat, benefiting from government price regulations and its historical abundance and versatility. Now, since we have large portion of our participants from textile and apparel, we've seen that textile and apparel industry in Philippines and Vietnam exhibits a higher degree of electrification. But this can be attributed to the fact that this countries primarily dominates the tier 3 process or the apparel production, which tends to rely more on the use of electricity than heat. So in general, with our location, our region's location, renewable energy sources such as solar radiation and biomass presents good opportunities for the implementation of clean heat solutions. And we and CEIA believe that by utilizing our local energy sources and embracing innovative technologies, Philippines, Vietnam, and Indonesia can develop sustainable and environmental friendly heating solutions. Next slide, please. Yeah. So due to some to our time constraints, I won't go into intensive details about each of the clean heat technologies along with their pros and cons. However, do note that our knowledge product contains the discussion, like quite extensive discussions of these working mechanisms, these pros and cons that can actually guide adopters into the suitability of various clean heat technologies in your facility. So please check it out in our knowledge product if you are interested. So next slide, please. Yeah. So aside from the biomass boilers and heat pumps and solar heaters in the previous slide, we also have discussions on waste heat recovery and electric boilers, should this be of interest. Next slide, please. So the reason why I skipped through those previous slides is that I would like us to focus more on this slide, which is the technology selection frameworks for the facilities. So the previous table from the previous slides could come as a guide for us to use if we are trying to determine the clean heat solutions that could fit our facilities. And this framework that was shown here in this slide could guide us on where to begin. So choosing the appropriate clean heat technologies for our facilities is crucial in promoting sustainability and reducing the environmental impact of our operations. And assessing heating requirements is the first step of this process. So this involves understanding the specific needs of our facilities, such as the required heat output, temperature ranges, and heating durations. By conducting thorough assessment of your heating requirements, you can effectively filter out the technologies that cannot meet actually your specific heating needs. And among technologies that were presented in the previous slide, biomass and electric boilers can actually offer a wider range when it comes to operating temperatures. However, another factor to consider actually is the energy resource availability on site. So evaluating the clean energy sources that can be harnessed for heating purpose is important as well. For example, if a facility receives viable, ample or stable amount of solar radiation with minimal shading, then a solar thermal system could also be a viable option. Electricity availability could also be another resource to be considered. If a facility has access to affordable electricity, then adoption of electric boilers and heat pumps could also make sense. However, we would need to note that if sustainability is the main consideration of shifting to clean heat, then identifying the electricity source of the grid is necessary, whether our grid is actually powered by coal or by renewables. Base loads like hydro and geothermal would also be something that we need to look into. Similarly, if there is access to biomass, then the use of biomass boilers can also be considered. For example, from our Vietnam team's assessment, Vietnam can produce 2,565 megawatts of rice straw, for which 24 out of 63 provinces can have a potential for a capacity higher than 30 megawatts. Then facilities in these 24 regions may look into the potential use of biomass for heating. However, one thing to also note is that when considering biomass, it is necessary to address the sustainability aspect of biomass fuel sources. It is imperative for us to ensure that the biomass is obtained from responsibly managed forests or agricultural system to avoid any contribution to deforestation or adverse land use change. The next step is evaluating the technology performance. So it actually encompasses factors such as efficiency, reliability, maintenance requirements, and environmental impact. Evaluating the performance of different technologies allow for a comparison of their effectiveness in meeting the facility's heating needs. And it is vital to consider not only the cost of the solution, but also the long-term performance and operational costs associated. So among the technologies that we have discussed, heat pumps and waste heat recovery system are known to be energy efficient. Solar heaters are also considered to have longer lifespan because it doesn't have like moving parts, and it is considered to require low maintenance, making them one reliable options as well. Um, And however, on the other hand, biomass may emit unwanted emissions during the transport to facilities, and thus optimizing transport routes, utilizing cleaner mode of transport, and investing in efficient handling and storage infrastructure, and promoting the use of locally available biomass resources are considered to be necessary. So I just want to add this part that during the registration, we've actually asked the participants to ask any questions in advance. And there is actually one question that has actually caught my attention, and I think it is also relevant to address this in this part. So the question says, is biomass a clean heat? So yeah, so just to address that questions from one of our participants, uh, clean heat, as we defined it, actually typically refers to the heating methods that have a reduced environmental impact compared to conventional or traditional fossil-based heating. But we need to but another considerations with biomass as clean heat, or however, the cleanliness of biomass heating depends on various factors as well, including the source of biomass or the efficiency of combustion and the management of emissions. So if the biomass is harvested unsustainably, or if the combustion process is efficient, then it can lead to air pollution and contribute to environmental problems. Therefore, yeah, to be considered a clean heat source, then biomass must meet like a specific criteria for sustainability and emission management. And I think that the discussion later from Tanya can also give more context on this one. So I hope that answers that particular question. So moving forward as well, estimating initial investment, operating costs, payback period, and potential savings over time is crucial to determine the financial viability of adopting clean heat technologies and in making informed decisions. Environmental impact evaluations are also essential. Take into consideration the greenhouse gas emission, air quality implications, and overall environmental footprint associated with each clean technologies. Lastly, seeking expert advice is highly recommended during this entire process, engaging with professional consultants or technology providers who can provide valuable insights and guidance. Next slide, please. So to end this presentation, I would like to leave you with these three key takeaways. The first one is that clean heat solutions presents opportunities for our region's economic growth. So the Philippines, Vietnam, and Indonesia we are experiencing rapid economic growth and industrial development, leading for us to have increased energy demand, especially for process heating. And embracing clean heat technologies in these countries, in our countries, present an opportunity for us to address environmental challenges and align energy strategies with national commitments, and also achieve substantial energy savings and cost reductions. The next highlight is that key the next key takeaway is that we actually have some successful deployments. However, there are still challenges that remains for widespread adoption. So case study that will be presented later by our corporate partners offers valuable insights into opportunities for clean heat deployment, such as the potential for reducing greenhouse gas emission, enhancing energy efficiency, and promoting sustainable development. But challenges such as availability and sustainability of feedstock and initial investment cost of technologies and the need for supportive policy framework still requires careful considerations. And the last takeaway is that for the first step for this one is raising awareness and understanding clean heat technologies. So clean heat encompasses a broad range of technologies and approaches, and the initial step really is to integrate clean heat into corporate decarbonization, is to raise awareness and foster deeper understanding of technologies in their deployment. So this is actually the reason why we're doing this knowledge product and disseminating it in today's event to raise awareness and understanding about clean heat solutions. Next slide, please. Yeah, I think that ends my presentation, and I would like to express my sincere thanks to our corporate partners and contributors who have generously accommodated our team throughout the series of interviews and focus group discussions to really develop this knowledge product. Yeah, I hope we were able to share some new stuff and insights, and thank you all for your kind attention.
All right, thank you so much, Alni, for that wonderful presentation. And just to inform everybody, we all have a chance later to ask more questions and for your questions to be answered later during the panel discussion and the Q&A portion. So please just feel free to send out your questions in the Q&A box as well. All right, so proceeding now to the next part of the program, we will now be seeing a presentation on the insights from CEIA Indonesia biomass co-firing in the textile industry, to be presented by Arlisa Nathania Hutagalung. So Ms. Tanya holds an urban planning degree from Bandung Institute of Technology and has 3 years experience in demand-driven projects that support renewable energy. She's the current energy analyst in World Resources Institute, with her current research focus is on industrial decarbonization through low carbon technology solutions mapping and clean heat technology exploration. So Tanya, the virtual floor is yours.
Thank you, Ivan, for the introduction, but I think I have a technical issues in terms of sharing my screen.
Okay, let me see if I can share from my end, Tanya.
I think it's all good, Ivan. Thank you. Okay, so thank you, Ivan, for the introduction. Hi, everyone. My name is Tania, the energy analyst from WRI. And in this session, I'm going to share to you the insights on biomass co-firing for industrial process heat for textile and apparel industry that we have conducted a couple years. But before I'm going to deep dive on the boiler technologies and also the pilot insights, I'm going to give you a briefly overview first about to understand the characteristic of textile industries. So maybe as you have already familiar with, the textile industries comprises of 4 tiering. The tiring 1 is on the assembly, tiring 2 is on the fabric making, tire 3 is on the yarn making, and tire 4 is on the extraction. But in here in Indonesia, we actually classified those 4 tiers into 3 streams: the up, the mid, and the downstreams. Basically, it's the same classification, but we exclude the tier 4, the extraction, because it falls under the basic chemical industrial sectors. So in here, you can see different kind of processes in different upstreams with different product examples. But the interesting part is that each stream has different characteristic. For example, the upstream is the most capital intensive one, and it employs the least workforce among other streams. And also for the midstream, the technology development in the stream is quite more progressive than the upstream, and it has a semi-intensive capital. And whereas the downstream, it employs the most workforce among other streams, in which mostly the workforce is female workforce. And the technology in the stream is is rapidly evolving. And in this stream as well, the scope 3 emission is the highest among other streams because it embeds emissions in production inputs from from the previous streams, which is the up and the mid streams. So here is the energy profile of textile industry. As Alni has mentioned previously, textile industry dominantly use electricity energy, in which you can see from the data, those 3 streams consumes electricity the most, except the weaving industry, which dominantly consume heat energy the most. So before we're going to continue to discuss further about biomass boiler technologies and the pilot, I'm just going to give you an overview of technology solutions mapping that we have conducted for several times for textile and apparel industries. And note that this, and a little bit of disclaimer, this is still an ongoing process of analysis. So an updates might be needed for couples of time for the next, in advance. So as you can see, we kind of classified the solutions for low carbon technology in 3 different kinds of way. The first one is the process specific one, meaning that the solutions that we map is only applicable to a specific process in the specific subsectors. And then the second one is the sector-wise, meaning that these kind of solutions can be applied to all of the subsectors underneath the textile and apparel industries, regardless of the streams, regardless of the process. It can be applied generally. And then the last one is the operating procedures, which we classified these solutions. The solutions can optimize the operation procedures in the industries. Okay, so we kind of classified these solutions as well into its technology readiness level. So as you can see, there are 2 colors, the yellow one and then the red one. The yellow one, we kind of identified the solutions that has a TRL level above 9, meaning that these solutions are already massively applicable in the market, whereas the TRL below 9 that we kind of color coded here in the red color, meaning that the solutions are still under development. So I'm going to focus on the biomass fuel conversion in boiler. It is specified as the sector-wide categories and the fuel switching categories. And these solutions can be applied to across all subsectors in the textile and apparel industries, regardless of the process. So it's a general solutions. So here's an example of illustrations of how the heat biomass boiler can be applied to certain industries. So this is the intervention of fuel switching solutions using biomass conversion for heat. And these illustrations that I get is the nylon making process. So as you can see, the heat from the biomass boiler can tackle or can reduce emission produced from several processes, which are extruding, dyeing, and also the finishing. And also these 3 processes falls into the categories of medium temperatures, which falls under the 130 degrees until 500 degrees Celsius. So even though I'm not a biomass boiler expert, as we have Mas Anggit Dwi Pramana here as our biomass expert. So if you have any questions, further questions regarding the technicalities of the biomass boiler technology, feel free to ask him in the chat box below. But I'm going to give you a general overview of different types of boiler technologies and where it can be applied to different types of industrial sizes. So boiler technology can be classified into two factors. The first one is based on its water flow position, and the second one is based on its combustion technique. So based on the water flow position, boiler can be classified into, there are two types of boiler. The first one is the fire tube, which can be applied to small scale industries, and the water tube, which can be applied to the medium to large scale industries. And for the boiler classification based on combustion technique, there are 5 types of boiler. The first one is the grate or stoker fired, which can be applied to across all scales of industries. And then there is a fluidized bed, which has 2 types of the fluidized bed, the bubbling one and the circulating one. The third type is the pulverized fuel, which only can be applied to the large scale industries. And then there are 2 other types, the burner fired and the waste heat. So as you can see here, not all types of boiler classified based on its combustion technique can be applied for the biomass co-firing, can be feasible to do biomass co-firing, only certain types, which are the stoker fired, fluidized bed, and also the pulverized fuel. In terms of the other 2 types, the burner fired, it can only use oil and gas fuel, and also the waste heat, even though these 2 types of boiler can be applied to all scales of industrial sizes. So in here, I'm going to give you a brief overview of our assessment on the biomass feedstock. So the insight that we have is that the waste biomass is still the best option compared to other sources as alternative solutions for heat decarbonization. So in this graphic, you can see that we kind of analyze different types of fuel sources based on 2 factors. The x-axis represents the CO2 produced, and the y-axis represent the cost in terms, and this is still in the Indonesian rupiah per month. And the leftist and the lowest options are considered the best, whereas the rightist and the uppest options are considered the worst, because it means that they produce a high CO2 emissions and demands higher cost. And so there are several insights that we can gain from this graphic. The first one is that the biomass is still considered as the most low-hanging fruit, considering that we kind of analyze 3 different types of feedstock biomass, wood briquette, palm kernel shell, and kaju putih, and all of these 3 feedstock biomass falls into the leftist and the lowest part of the graphic. And then the second insight is that among of these 3 types of feedstocks, wood briquette is considered the most affordable, but it has a supply constraint because the supply kind of have a competition with the furniture and wood products itself. And the second most viable biomass option is the palm kernel shell waste. As you may know, here in Indonesia, we kind of have an abundance resources of palm kernel shell, but it might have a technical concern due to its high moisture content that might risk the technicalities issues on the boilers, and it has also a sustainability concern. And another insight is that another option is for industry to utilize gas from the PT-PGN. So PT-PGN is a state-owned enterprise that supply gas for industries. But the concern is that only a certain location is reached with the gas pipe. So not all industries can access the PGN gas. And the rest of the options, the CNG, electricity, and solar fuel are still pricey. But I'm going to give you a disclaimer that we kind of analyze these 3 types of feedstocks with the assumption of emission produced used in the analysis has an emission factors of 0, because we kind of have a limitation data to calculate the emission produced from the transportation and also the production. The production meaning the feedstock has an additional process, like, for example, briquetting or pelleting. But the ideal part is that you should calculate these kind of emissions, the transportation and also the additional processing of the feedstock. So this is my last slide. This is the pilot results and lessons learned of piloting biomass boiler co-firing for an apparel brand supply chain partners. So basically what we have done with the supply chain partners of textile industries is that the first part is we kind of identified the best feedstock available in the market, uh, considering the price and also its sustainability indicator, its sustainability performance as well. We've find the feedstock supplier, and then we kind of matchmaking the feedstock supplier with the brand and also the supply chain partners. And eventually we conducted a pilot project. So these are the details of the pilot. So the boiler type used is the stoker fired stationary or fixed bed with boiler capacity 6 ton per hour, and this is considered as small. With feedstock type, Kaju Putih briquette waste. That's why we kind of included the Kaju Putih feedstock type in the analysis in the previous slides. With calorific value about 4,000 kilocalories per kilogram. And this is the interesting part, the price. So the feedstock price of the Kaju Putih approximately 170 US dollar per ton, including briquetting, processing, and transportation costs, whereas the coal price is 70 US dollar per ton. And disclaimer as well, Indonesia has a price cap policy for coal. So this is the maximum price for coal that can be sold in the market, in the Indonesian market. So in terms of the price, it's kind of like doubling the coal price. So the price is definitely an issue in terms of um, using biomass, the Kaju Putih feedstock one. And then for the trial duration, we conducted for 2 days long and 100% co-firing percentage. And the trial result is success, and there was no technical issues. The operation was stable, and we calculated the emission abated approximately about, it can reduce about 28.4 ton CO2 emissions. So there are challenges during our assistance on the pilot biomass co-firing project. The first one is that the Kaju Putih waste feedstock supplier has a constraint to supply feedstock consistently to the supply chain partners. So in terms of the options of Kaju Putih waste feedstock, it kind of have like a concern because the feedstock supplier cannot guarantee a long-term contract with the supply chain partners, whereas the supply chain partners really want a long-term contract to secure its sustainability. And then the second one is that the price is too high compared to coal and other feedstock, regardless of its high sustainability performance. So the underlying reasons of why we choose the Kaju Putih waste feedstock is because of the highest sustainability performance compared to other feedstock like wood pellet or sawdust or palm kernel shell, but the price is too high. And then the options like palm kernel shell is kind of more preferable to the supply chain partners. However, the brand doesn't yet have a standing point on palm kernel shell sustainability. So it kind of gave an uncertainty to the supply chain partners, whereas they can use the palm kernel shell because the price is lower than the Kaju Putih one. So the lessons learned are there has to be a middle ground in choosing preferred biomass feedstock, both from the brand and also the supply chain partners. Biomass is still a feasible option for decarbonization, but only as a transition solution due to its biodiversity and sustainability concern. For long-term, electrification should be prioritized. So as Alni has mentioned previously, that eventually Vietnam and the Philippines has a high electrification in terms of the textile and apparel industries, whereas in Indonesia, to electrify the boiler, it still has a price concern. And the last lessons learned is that a collaboration with the government can help to raise issues on biomass position within the decarbonization pathway. So this is basically what we do. We kind of escalated the pilot projects by collaborating with the Directorate of Bioenergy, the Ministry of Energy and Mineral Resources, to create a technical conversion biomass boiler guidelines for industries, and also to create a policy brief on the sustainability aspect of the biomass and also its positioning in the pathway of industrial decarbonization. So yeah, I think that's all from my side. Thank you, everyone, for your time. I'm going to give the floor back to Ivan.
Thank you so much, Tanya, for that presentation. And I'm seeing that we have several questions already in the Q&A box and in the chat box as well. So yeah, we will try our very best to answer all of those questions. So maybe while the presentation are ongoing, we have someone from our team to already start answering these questions. So yes, Tanya, thank you so much. Um, and at this juncture of our program, we can now proceed to our case study sharing session, wherein we will be hearing from industry experts from the Philippines, Vietnam, and Indonesia to share their knowledge and their experience in their respective field of expertise. So we will start with the biomass boiler in Philippines sugar mills to be presented by Miss Rosemary Gomera, as we fondly called her, Miss Maru. So Miss Maru is a chemical engineer by profession with work experience spanning 4 decades in the fields of chemical engineering, research, policy, and planning. She started her career in the sugar industry in 2002 under the Sugar Regulatory Administration, or SRA. So Ms. Gomera is currently a consultant and industry expert for the Confederation of Sugar Producers Association, Inc. of the Philippines. Everyone, please give a virtual round of applause for Ms. Rosemary Gomera. Ms. Maru,
Yeah.
the floor is yours.
Thank you, Ivan, for that kind introduction. And I'll be speaking in behalf of Mr. Oscar Cortez of the Philippine Sugar Millers Association, because unfortunately he wouldn't be able to join us for because of some important matters. So first, I'd like to share for what. Okay. Okay. So my presentation will be focused on clean heat from bagasse, which is a residue from the extraction of sugarcane juice from the sugarcane plant. So we call it bagasse in the Philippines, and I think also in other countries. So let me provide you first an overview of the Philippine sugar milling industry. So in the Philippines, we have currently, the previous crop year, we have 26 operating sugar mills. And the total rated capacity of these sugar mills is 186,700 tons cane per day. So that's our supposed to be ideal utilization of sugar cane per day of the 26 sugar mills. And the sugar cane is being supplied from 384,000 hectares of plantation planted by 92,000 farmers, wherein about 93% of these small farmers are tilling 10 hectares and below. Then in that particular crop year, the 26 operating sugar mills produced about 1.8 million tons of raw sugar and around 6.2 million metric tons of bagasse. And we also produced about 847 tons of molasses, which is now a major feedstock for the production of ethanol in the Philippines. And from there, the 26 mills utilized 20.5 million tons of cane for the production of raw sugar. And you can see that we really have a problem in terms of our feedstock supply, because the main reason why the capacity utilization of our sugar mills is only 49% because of a sustainable supply of sugarcane as feedstock for the production of sugar. Then it's so sad to say that currently our sugar yield is very low. We are at 1.77 50 kilobags per ton cane. So that's equivalent to about 8.85% sugar in cane. But then the sugarcane industry in the Philippines is actually a major contributor to our economy. So in terms of GDP, the sugar milling industry contributes about 136 billion, which is equivalent to about $2.4 billion, and a value-adding contribution to the economy of about 131 billion, or about $2.3 billion. All sugar mills in the Philippines use clean heat from bagasse in the production of raw sugar, and we have also 12 sugar refineries which are also using cane bagasse for its heating, for its heating requirement for the production of refined sugar. So we have our 26 sugar mills have a total of 80 units of bagasse-based boilers. These are the data that we gathered as of the 2022 based on the equipment audit of the Sugar Regulatory Administration. And it has a total installed capacity of about 6,346 tons bagasse per hour, ranging from a low of 18 tons per hour to a high of 200 tons bagasse per hour. So that's the capacity of our boilers. And we have a total of 83 units of steam turbine. So with a total power capacity of 453,962 kilowatts, ranging from a low of 720 kilowatts to a high of 30,000 kilowatts. And we also have 8 sugar mills who invested in the sale and generation and sale of power to the grid using bagasse-based power. So with a total capacity of 273 kilowatts. This is the latest report as of August 31, 2023. So this is guided by the report published by the Department of Energy. So we're in the largest sugar mill producing. This power is actually Crystal Sugar in Bukidnon. So this is a province somewhere in Mindanao in the Philippines. So producing 49.3, installing with an installation capacity of 49.3 megawatts. So followed by Biscom in Negros Occidental with an installed capacity of 48.5 megawatts, followed by URC, Universal Robina Corporation, Sonedco, by the Victoria's Milling Company, both in Negros Occidental, Central Azucarera de Baez of Negros Oriental, Hawaiian Philippines Company, Sugar Company in Negros Occidental, First Farmers Holdings in Negros Occidental, which is the pioneer actually among all the sugar mills in the Philippines who installed and sold power to the grid. It's the First Farmers Holdings Corporation. Then the last one is Central Azucarera de San Antonio, located in Panay. The key drivers in the Philippines for the deployment of biomass boilers are the following. First and foremost is the technological evolution in sugar processing. So in the past, sugar manufacture is mainly using open pan boiling for the evaporation of water from the sugar cane juice and crystallization of sugar. And now they're using steam. The industry is using steam for the evaporation of water from sugar cane juice and the crystallization of sugar. Then the second driver is process optimization and cost reduction. Because we wanted to improve our efficiency or utilization of energy from bagasse, so we need to optimize our process and install more high pressure steam boilers for bagasse-based boilers for our for the processing of raw sugar. And at the same time, this is also a cost reduction effort rather than using fossil fuel alone. And also part of our environmental management, wherein in the past, bagasse is actually a problem in the Philippines of our sugar mills because before the advent of this process optimization and the succeeding laws with mandates for renewable energy. So in the past, bagasse has been piled up in the sugar mill, and actually it's been an environmental problem which is difficult to manage on the part of the sugar mill. It is also a fire hazard on the part of the sugar mills. And upon the issuance of the Renewable Energy Act of 2008, which provides incentives for renewable energy developer wherein biomass is one of the renewable energy identified under the Act. So the eight sugar mills I have mentioned before, they are the ones who ventured or invested for more or high pressured boilers in order to produce more power for sale to the grid. So that motivates our investors and our sugar mills to invest in high pressured boilers so that they can sell power to the grid. And at the same time, it will be an additional revenue stream for the sugar mills. Then the last one is the passage of the Energy Efficiency and Conservation Act. So under this Energy Efficiency and Conservation Act in the Philippines, this mandates all establishments to adopt measures of reducing or to be efficient in the production and the utilization of energy, and promoting the use of clean energy or green energy for their operations. So the sugar mills also actively participated in this one. They wanted to improve, to be compliant with this particular act, which also provides incentives to the sugar mills in the acquisition of equipment for energy, for making their operations more efficient in terms of energy utilization. Then for a while. However, there are several barriers in the case of the Philippines and on the use of biomass boilers in the Philippines or clean heat from sugarcane bagasse. There are also technological and non-technical barriers for the deployment of these boilers in the Philippines. And I think there are similar situations which were presented already by the Indonesia CEIA team. And for a while. Okay. The first barrier is if we wanted to install a high pressure boiler, the sugar mills need an entire modification of its energy system. So this means in order to align the equipment, all the equipments of the energy system to the boiler's design and capacity, they need huge investment. So only a few of them were able to invest because of this invest on high pressure boilers, because of this requirement on huge investment wherein other equipment across the entire energy system of a particular sugar mill should be adjusted, and you need to modify them or to replace them or to upgrade them. So another barrier is the unreliable supply of cane. So the supply of cane to the sugar mills is not sustainable, and it causes unstable operations. It causes unstable operations on the part of the sugar mills, and their target process and energy efficiency were not met actually, and were not attained because of this unsustainable supply of sugarcane. Then the inadequate facilities for the transmission of power to the grid is also a major problem on those mills which invested for under the Renewable Energy Act, which invested of upgrading their boilers and energy systems just to generate power for sale to the grid. So they are made actually to cut off or to curtail their power generation in order not to overload the grid. So because of this curtailment and the problem of transmission to the grid, the power that they produce, majority of these mills which invested on bagasse-based power for supply to the grid encountered negative or very low return on investment. So these are the three major setbacks in the Philippines on the part of the sugar mills investing for the generation and sale of clean heat from bagasse. Now, these are our practical recommendations in case other countries will also venture into the production and generation of clean heat from bagasse or a sugarcane residue from bagasse. So government infrastructure to support the generation and sale of biomass power to the grid should be in place. So during the passage of the Renewable Energy Act, so there are government agencies assigned actually to be to be the ones in charge in terms of infrastructure, but maybe the installation of this infrastructure is not timely, and the power plants, bagasse-based power plants were already in place. So there should be the timing of the installation. So until now, the facilities for the transmission lines to the grid are not fully in place. So this caused some setback for the implementation of the biomass based power here in the Philippines. Then we recommend that the government should revisit the feed-in tariff scheme for sustained incentives to renewable energy developers, because in the case of biomass, we were allocated only about 250 kilowatts or megawatts, which will be enrolled under the feed-in tariff scheme, and it has been fully subscribed in 2019. So because currently we have 273 megawatts, and we reached the 250 megawatts allocation in 2019, and we need to revisit the feed-in tariff scheme, which will promote more investment in biomass. Right now, the Department of Energy, or through the Energy Regulatory Commission, has implemented a program after that the expiration of that feed-in tariff scheme. They implemented this green energy auction program, wherein they offered a ceiling price through bidding. They established a ceiling price for the power. Right now, it's about 5 pesos and 40 centavos compared to the feed-in tariff before, which is 6 pesos and 63 centavos. So it's lower, but still it's above the market price. So that's an incentive for prospective investors in terms of biomass-based power. Then, as mentioned also by Indonesia, the sustainable supply of feedstock is a very important one. Wherein in the Philippines, we need government support for sustainable agriculture, in the generation or production of biomass crops. So not only for sugarcane, because we have prospects for other biomass crops in the Philippines like coconut, corn, or maybe forest products also. But then in terms of agricultural crops, the most prospective crops in the Philippines aside from sugarcane, I think is corn and coconut. So this is the last active slide of my presentation, and thank you.
Thank you so much, Ms. Maru, for that presentation. Yeah, we will definitely see you back in the panel discussion. I think there are also some questions already addressed to you, but yeah, we can answer that there. Just for the benefit of time, we will now be proceeding to the next presentation, which is from the solar heaters and heat pump in Vietnam, to be presented by the head of sales and business development of Solar BK Vietnam, Mr. Nguyen Tin. So Mr. Tin is a highly accomplished professional with a bachelor's degree in control and automation from Hanoi University of Science and Technology, earned in 2006. So during his tenure at Solar BK, Mr. Tin has held various key positions, starting as a system design engineer and eventually advancing to become the head of sales and business development. So Mr. Tin, the virtual floor is yours. Thank you so much.
Okay, thank you, Ivan. Let me share screen. Can you see my screen, right?
Yes.
Okay, great. Hi, everybody. This is Thịnh Nguyễn from Solar BK. It's my honor to be here today to talking about the application of boiler, thermal water heating, and heat pump application in Vietnam. So you know that we have several common types of industrial boiler in application, like oil and gas boiler, biomass boiler, and electrical boiler, and is appear in wide range of application like food processing, garment, textile, rubber, and woodworking, etc. So you know that the solar water heating system, the working principle is quite simple. It's based on the natural thermal convection and the glass cage effect to convert irradiance energy into heat energy. In industrial scale, is normally combined the solar water heating system with heat pumps to ensure the flow and temperature. So take advantage of solar radiance to convert it into heat energy. The operation and maintenance cost of the solar water heating is very low. It's take only roughly 10% of electricity to using with heat pump to stabilize the temperature. And for the heat pump, you know that heat pump basically is like air conditioner, but working in reverse. So the key factor here is the coefficient of performance of heat pump, the COP. The COP heat pump is 4. It means that when to generate 4 kilowatt hour of thermal energy, we just need only 1 kilowatt hour of electricity. But instead of we using gas or oil, the COP is only 0.85. It means that the heat pump, the efficiency of heat pump is higher than the traditional method, more than 4 times. So you can see on the screen is this is the saving cost of the heat pump compared all the traditional heating methods, and it's based on the energy and fuel costs in Vietnam. In Vietnam currently, you can see if we're using the resistor for heating 1,000 liter of water from 27 degree to 60 degree, we take roughly almost $4. But we using the heat pump, the cost is $0.8 per 1,000 liter. So you can see that the heat pump is a significant saving cost compared to the other method like a resistor, diesel, or gas. And the saving CO2 of the heat pump, you can see on the screen. The heat traditional method total emission will be roughly 36 kg for heating 1,000 liter of water from 27 to 60, and a heat pump is a significant reduce the CO2 emission. And solar water heating is just only 3 kg CO2 to heating the water. You can see. Yes, and this is the example of configuration of solar water heater and heat pump in textile industry that we applied in our several projects. We combined the solar water heating and combined with the water tank and the heat pump and the water will be preheat and using for the boiler, and this combination will have reduced roughly $3 per 1,000 of hot water saving costs. This is our several case study we applied for some other case study we applied for the seafood industry. For this factory, the demand of the hot water is 23,000 liter a day, and the current resistance system heating system efficiency is very low, approximately roughly 60% efficiency. So we combine the resistance system with the solar water heating and heat pump. And for this project, we can saving a year for the client $17,000 per year and reduce the CO2 211 tons a year. And you can see on the screen. Okay, so for some other for all those kind of project, we apply the monitoring system to monitor how much we're saving by the solar, how much we can saving by the heat pump, and compare it to the traditional method. And for this model, Basically, in Vietnam, we applied the model that we invest and the client can enjoy the saving by the and energy efficiency saving, like a ESCO model. And just a bit talking about the solar BK, and because actually we are Vietnamese company here in Vietnam, and we manufacture the PV panel and solar water heating in Vietnam. And this is some reference project for the solar water heating we applied in Vietnam and Myanmar, like a hotel in Myanmar, or the rich factory in Vietnam, and the hospital, and some several projects regarding to the rooftop solar. Yeah. So that is the brief information regarding to the solar water heating, and I just give some number for you can see the saving cost of the solar water heating and combined with the heat pump in Vietnam. Okay, thank you.
Thank you so much, Tin, for that presentation. And then next, I think we can proceed with the last presenter for this case study sharing session on waste heat recovery in an Indonesian food processing industry, to be presented by Mr. Suresh Masal, which he has 12 years of work experience in a cooling and heating solution, and he serves as sales manager for PT Thermax International, Indonesia. So managing sales and after-sales operations for Indonesia, Malaysia, and Singapore based at Jakarta, Indonesia. Mr. Suresh, kindly take it away.
Yeah, thank you, Mr. Ion, and thank you for giving this opportunity to present ourselves in this panel. So I am sharing my screen. Yeah. So today I am presenting energy efficient cooling and heating solution from the waste heat recovery system.
Sorry,
this
Suresh, you sharing your
Yeah.
screen already?
Yeah, not able to see.
Yes. Can you try again, please?
Let me. Yeah, sorry.
There you go. Thank you so much.
Yeah, so I am presenting the presentation on energy efficient cooling and heating solution. So by the waste heat recovery system. So the main aim is conserving resources, preserving the features. So I think our vision is to be globally respected high performance organization offering sustainable solution in energy and environment. That is Thermax. So we have a state-of-art manufacturing plant in southern part of India. We are manufacturing 400 plus chillers annually. Two subsidiaries in Thermax USA and Thermax Europe. We have direct sales and service presence over 15 countries, 7,000 plus installations. So largest export of absorption chillers in the world. So for today's session, sorry. Yeah. So type of waste heat in the industries. So waste heat from air compressor. So waste heat from gas turbine or gas engine. Waste heat from potato chips fryer. Waste heat from a noodle fryer, or any other source of heat with hot water temperature ranging from 70 degree to 180 degree can be used to drive chiller heater or heat pump. So best solution for this, we have absorption cooling and technology.
Tapi nggak
Yeah,
ada
sorry.
itu. KWH-nya berapa? Oh, masa KWH-nya? Ya gimana kalian? Apa? Ya, kalau kayak gitu,
Sorry
Yeah,
for
sorry.
that, Suresh. Sorry
Yeah,
for
yeah.
that. Okay.
Yeah, yeah. So these are the types of heat which normally available in any industries. So waste heat from air compressor, waste heat from gas turbine, gas engine, waste heat from potato chips fryer, so waste heat from noodle fryer, or any other heat source from hot water temperature ranging from 70 degree to 180 degree can be used to generate cooling or heating. So for this, there technologies available. That the technology is called absorption cooling and heating technology. So why this technology? So normally the lower operating cost, low on maintenance cost, environment friendly. Okay, environment friendly refrigerant is used in this technology. So zero ozone depletion potential, zero global warming potential. There are no moving parts, no vibration. So it's a silent operation. So waste heat, this normally works on the waste heat. So very low electrical power consumption. So there is no wear and tear. So no or low downtime. So this is the technology actually. So left side you can see the type of heat available, and the right side the utilities we can provide. So here steam from zero. Now this steam normally, if it is in waste, we can consider as a waste heat. Normally our main focus is recovered waste heat from flue gas, from gas engine or gas turbine. The temperature ranging from 250 degree to 600 degree Celsius. Hot water from gas engine or heat recovery unit or compressor heat. Temperature from 60 degree to 220 degree can be used as a heat input and to generate cooling or heating solution. So process induced waste heat, that is vapor from chemical reactor, polymerization column, or potato chips or noodle fryer. That vapor can be used to drive this system and to generate chilled water or hot water. Renewable heat from geothermal or solar, so can be used to provide this cooling and heating utilities. So what are the main drivers to deploy this system? So any industry, so that there will be cooling and heating requirement. So that is the first thing. Second thing, so normally the energy conservation, everybody wants energy conservation or reduce global warming potential, to reduce the carbon emission. So our implementing green energy solution. So based on that, we can decide which product or technology to be given or to be supplied to meet their requirement. So depends then again, market opportunity depends on the type of industries. If have any captive power generation, so then scope of increasing overall efficiency by recovering flue gas from the gas engine or gas turbine. If there is a food industry or they are producing potato chips or noodle processing industry, then vapor from chips or noodle fryer can be recovered by absorption chiller, and then heating and cooling can be produced. So the chilled water, then if there is a chiller, the chilled water can be used for air conditioning or packaging area. If hot water, that hot water can be used for heating application. So any process waste heat that can be recovered by absorption technology to generate cooling and heating. So waste heat from sugar industry also can be generate hot water and chilled water by the absorption chiller. So this is the schematic layout for the potato chips production scheme. So here there will be continuous frying system. So potato normally contains 60 to 70% moisture in it when we fry in the fryer. So the vapor will be released at 100 to 115 degree. That vapor, normally this is waste. So that waste can be used to drive this chiller, and then we can generate cooling or heating based on the application. And then if it is whatever, then after this vapor consumption, the condensate that can be used for the cleaning process. Yeah, this is the scheme for noodle production. So here there will be noodle fryer, noodle or pasta fryer. So same process, 100 degree or 115 degree vapor can be generated here. That vapor can be used to drive the chiller, and then the chiller output can be used for the cooling or heating application, and then condensate can be used for other cleaning or other process. In sugar also, here in sugar industry also, there is a heat generated here, vapor at 70 to 75 degree, and that normally that vapor is given to the condenser, and in condenser with the help of cooling water, that vapor get condensed. So that vapor we can take it to the heat exchanger, and we can generate hot water, and that hot water we can give absorption chiller, and then that output from the chiller can be used for the cooling and heating application. This is a non-dairy cream production. So in this also, any waste heat can be used to drive the chiller. So here normally 80 to 90 degree, normally that is given to the heat exchanger, and that with the help of cooling water, that heat is getting rejected in the cooling tower. So that heat we can give to the chiller, and that chiller output from the chiller can be used for cooling and heating application. So what are the challenges and opportunities? So their main challenges, so normally this is a retrofit kind of project. So installation challenges there if less space is available. Since the pressure of vapor or flue gas is very less, so to avoid back pressure, we need to install a recovery system close to the heat source. So there are chances of oil carryover with the vapor, water vapor from the chips or noodle fryer. So need regular cleaning. So opportunities, cooling and heating requirement can be generated using this waste heat from the noodle or potato chips fryer, process heat from sugar industry or any other food industry. This is a green solution actually for the industrial cooling and heating requirement, energy conservation, and of course there is a saving. So these are the installation pictures typically. So the first picture is this is from PepsiCo Africa. So you can see this chimney. This is actually coming from the fryer, potato chips fryer. PepsiCo is manufacturing Lay's chips, and this is a chimney from the fryer. And we will take tapping from here, and we'll connect to this chiller. This chiller output is a chilled water, and as well as there is a heating circuit is also there. So that chilled water can be used to air conditioning of their packaging area, and then hot water, whatever is generated here, can be given to the cleaning process, CIP process. Yeah, that's it. Thank you, Ivan.
Thank you, Suresh, for that presentation. All right. So I'm looking at the time. I know we're kind of behind schedule, but seeing that we want this to be as productive as possible, maybe there's just a possibility that maybe this event would just be extended by maybe 5 to 10 minutes. So for now, we can now proceed to the interactive discussion and the Q&A portion. So again, I would like to request again the panelists, Maru, Suresh, and Tin, to come back to open again their cameras for this one. And alongside them, we will also be joined by another panelist. I will be introducing Mr. Ananto Wimpaji, the Senior Climate and Energy Manager for Adidas Sourcing Limited. So Mr. Ananto is a highly accomplished sustainability professional with over 20 years of experience in the apparel, footwear, and chemical industries. In his current role as Senior Climate and Energy Manager at Adidas, he is responsible for developing and implementing strategies to decarbonize the company's supply chain. So Mr. Ananto, welcome as well to the panel. And this will be, I would also like to ask again Alni, who will be moderating this Q&A and panel discussion. Alni?
Thank you, Ivan. Yes, thank you, Ivan, and welcome back to the panel. Thank you for your presentations earlier. They're truly insightful. And yeah, we've actually got a lot of questions from the audience that we would wish to address during this panel discussion. So yeah, I think we can start off with some of the common questions from our audience, shall we? Which is actually more on the ensuring the sustainability of biomass. So I think one common questions that we actually see from the audience is how can we actually ensure the traceability and verifications of wood briquettes, and I think this is also applicable to biomass in general. So how do we actually confirm that they were originating from sustainable resources? And I think I could ask Shores on this, and Mamaru can also add on to this, given your experience with sugar millers industry. So can we start with Shores on this one?
Yeah.
Yeah. If you have some experience on with Thermax with your previous operations before, do you have this experience on having clients that would want you to ensure that the sources of their biomass is sustainable, which is definitely a must to any sustainability implementations, right? Do you have some guidelines or some certifications or some processes that you do to ensure that you are actually or getting biomass from sustainable resources?
Yeah, actually, we have a boiler in food industries in Indonesia that is run on PKS as a fuel and rice husk also. So in Nestle in Bintang beer, and then now recently we are commissioning one boiler at PMI, that is a cigarette company. So yeah, we have experience on biomass fuel. So we are supplying biomass boiler also. So
Yeah.
that is normally based on PKS and this rice husk.
And for this one, how do you actually how do you usually check whether this biomass were sourced sustainably?
Yeah, normally, see, I have limited knowledge on the biomass as a fuel. So because my expertise is on the cooling side. Okay, so I have other team on this part. But yeah, we have experience on the biomass uses for the
Yeah.
boiler.
Okay.
Yeah.
It's Ali.
Yeah, yes. Thank you, Suresh. Yeah, Mamaru, do you have some
Yeah,
thoughts on
actually,
this?
yeah, Miss Aldi, in that particular concern, although I'm not aware on the level of on the use of wood pellets here in the Philippines for biomass heat, but then in terms of the use of wood pellets, especially here in the Philippines, we need to consider if that particular wood is not will not cause any forest degradation. So we also have an environmental and natural resource bureau here in the Philippines who takes care of that. And I think that's already taken care of. There are policies for that one in terms of the use of wood pellets for the generation of clean heat. But then our major concern is actually it should not cause any forest degradation that will cause climate change, that will cause flooding here in our provinces in the Philippines. And my second concern, especially on the sustainability on sourcing our various biomass resources, is actually we should know or we should be capacitated on how to measure the sustainability of those feedstocks in terms of its carbon emissions. So we need to know the benchmark level of its scope 1, scope 2, scope 3. We need those things. We need to capacitate. That's my concern also in terms of clean heat from bagasse or from sugarcane. We need to have a tool rather than we're spending millions actually if we want to measure our greenhouse gas emissions. We need to outsource those one. They will spend millions. What I'm thinking of, our technical personnel in the mills should have this particular knowledge or protocol on how to measure this greenhouse gas emission, and we should have that particular software which is adopted internationally or globally to measure scope 1, scope 2, and scope 3 GHG emissions. So that's my major concern, Miss Ali, and I think all of us here, because you know already, you're very aware, the World Resources Institute is the one developing this GHG protocol. So we need to capacitate our technical person in each country on how to measure this one, so that at any point in time, we could assess our level of sustainability, level of decarbonization.
Yes, thank you, Mamaru. I think that is indeed also an interesting insight. I think it's not just in the Philippines, but also I believe in Vietnam and Indonesia. I think the sustainability also lies with the standards that is also in alignment with the policies of the department or Ministry of Environment, right? And yeah, I think that the one that you have mentioned on the concerns and challenges is also something that that can be highlighted on the three countries, ensuring that the adopters are also knowledgeable on the scope 1, scope 3, scope 3 emissions, and how they can actually this installations can actually be benefiting from the reductions of those emissions. So yeah, thank you, Mamaru and Shoresh, for those responses on this one. And yeah, we also have some questions here related now to solar thermal solutions, which I think I can also now direct to Tin. So we have a question here on the operability of the solar thermal heaters, because this is one of the concerns, I guess, of also of the adopters of this technology. Can it operate during night, and how does it keep hot water temperature during the night?
Yeah. So regarding to the solar water, I think all solution of the water heating system, definitely they have the thermal insulation tank, and the thermal insulation tank to keep to minimize the heat loss overnight. Definitely is we have the loss, but we can minimize it. And normally at the nighttime we can the solar heating can using at the daytime, but for the nighttime we can use the heat pump or resistor instead of. Yep.
I see. So it's really it's also really like insulating and providing some backup heatings, right?
Yep.
Yeah. So I think that one is also like quite related on this one. So when we are actually installing these solar thermal solutions, how can we also ensure that this is properly sized in a facility, like it can be able to handle this demands both day and nighttime? Like I think it is more on how many like hectares or land or rooftop are actually needed, for example, for a certain factories, to ensure that we can be able to deliver the heat load of that certain factory, like from your previous experience.
I think for you know that actually the solar water heating is just only the support for preheat the water. So definitely we must have the base heating based on like electricity or the heat pump or a resistor to keep the temperature and the flow to be stable. And the solar is just a support for preheat the water. Yep.
Yeah. So you were like suggesting that heat pump is something that is heat pump and electricity boilers is something that could be the main one, and then the
Yep.
solar heaters can just be like a support. Like
Yes.
why do you why does it that why is the configuration that way?
The configuration that way, actually, the solar water is like at the upstream of the water, at the upstream of the water, and if the temperature or the and the flow is not enough, we must add the support from the heat pump and the electricity resistor.
I see.
Yep.
And how many land footprint do we need to have with these configurations of both heat pump and solar heater in a certain facilities? Do you have some estimates like hectares or square meters needed?
For the square
Yeah.
meter, I think actually is not exactly number, but for the is depend a lot on the demand, but I think is take it's not too much space on the roof for the several the factories take only, you know, uh 500 meters square for the system normally. It's not takes too much space on the roof, and definitely it's depend on the factory demand, on the client demand.
Yeah, because I think like the footprint is all I like the land footprint is also one of the considerations whenever we ask our corporate
Yeah.
partners on this one, like how many square meters can these technologies can actually take up. So right. So
Yeah.
yeah, thank you for that answer. And I think this one is also like applicable, like this question is also something that I can also ask perhaps to other technologies, like if I can ask Ma'am Maru as well, for example, for the biomass boilers for certain solar factories, how many land areas perhaps is needed to to meet the heat requirements of that specific plant requirements? Do you have idea?
Actually, I don't have an idea, but then that is a concern of the sugarcane industry, because most particularly in Negros Island, our main sugarcane producing province in the Philippines, there are several sugarcane lands in that province which were converted as solar farms. So that actually also a reduction of our sugarcane area, which provides us supply of sugarcane to the sugar mills. That's one of the constraints, the land conversion into solar and other uses. So I'm not so familiar in terms of the boiler capacities of those particular investment on solar.
Yes, I see. Noted on that. How about Mr. Soresh on your under social chiller technologies? Do you have also like uh uh estimates on the land footprints that are necessary should a company or a facility would like to incorporate these technologies in their facility?
Yeah, actually, for chiller, the space requirement is not much actually. So it's hardly so 10 by 10 meter is enough space. Yeah. As only the difficulty is in case of waste heat. So normally the pressure of that waste heat available is very less. So we need to install the chiller near to the heat source. That is the only challenge. Space is not challenge.
Yes, noted. Yeah. And yeah, I think I would also want to look in Ms. Pa Ananto on this discussion as well. Yeah, given your experience or as a part of corporate adapters and viewing the presentations from earlier, how do you actually view like clean heat, and how do you think is the greatest challenge to you as a corporate adapter on adopting these technologies and facilities? Like, you can also add more informations on what you think are the major considerations that you are looking into.
Okay, thank you, Miss Annie. I hope you can hear me.
Yes.
Okay, so yes, in Adidas, when we do the mapping of our supply chain emission, we found that 90% of our supply chain emission came from not supply chain emission. Our total emission 90% came from our supply chain, in which 50% of that emission of supply chain came from the heat itself, mainly coal at the time. So what we do is that we want, since we have our target to reduce our emission in 2030 and then in 2050 to be net zero. So that's why we want to phase out coal as fast as possible, as soon as possible. So in 2021, we start to do the planning. We do the checking in our supply chain, in which facility that we still have coal. And then we are checking what is the feasible solution to replace the coal in our supply chain. And one of them is we want to change coal to biomass. I think 90% of our supply chain would like to go for 90% of the emission from the supply chain we can want to convert into biomass, and the user of coal, and 10% of them is going for natural gas because its biomass is not available in that area. Because our supply chain is not just in Southeast Asia, but also like in Taiwan, China, and also Pakistan and Turkey, in which sometimes biomass is a challenge in there. But having known that our to reduce our supply chain with from coal into turn into biomass, there are technological solution, of course, because mainly the boilers itself is built for coal, and then second is about the biomass availability, and third is sustainability of the biomass itself.
Yes.
Regarding technology challenge, I think since we want to be moving as soon as possible, so mostly they go for modification from previously into from coal into modification into the biomass. Majority they do it. They can do it with low to no cost. Albeit the efficiency itself is slightly reduced, but not much, I think. Second, regarding the availability of biomass itself, we done the study. We conduct the study, especially into our main focus country, in which Indonesia and Vietnam, and then Indonesia. We do what is the available biomass in there, and what is the who is the vendor, what type of biomass, and then what is the challenge, and also what is the pro and con. Basically, it's market study, market assessment on that.
Mm-mm.
And then we found that we are quite having a lot of we have an abundant source of biomass in those two countries. Albeit we also competing with other industry as well, especially the power industry, and also in some not just other brand as well, because they want to move from biomass, move from coal. Third one is regarding sustainability. We know that sustainability is hard work, so it's not just us, because we are not the one who are in the supply chain. Maybe we have another brand, another stakeholder that is supply chain. So that's why we are we spread the word, finding information who can be our ally in coordinating to have the sustainable biomass. Luckily, we found MSMA. It is Mekong Sustainable Manufacturing Alliance, an initiative funded by USAID, driven by ISC in Thailand. They have the means, but they don't have the resource to do the to make that guideline. So they invite some of the big brand like Adidas, Gap, VF, and then Ralph Lauren, and also H&M. And here one of his contributor is Mr. Alan Chin here from VF Corporation. Is joining this discussion as well. We developed that sustainable biomass guideline in order to find in order first to define what is the sustainability in biomass, because sustainability is not just mean yes you have the certificate, that's it. So it's wide, but we need to find out what is the feasible, what is the sustainable means by this brand. And then also we have tools that can be used by the factory when they want to, or even the brands, to decide which sustainable biomass, which biomass is sustainable that they can use. So basically, we want to have industrial standard to those biomass. More on like, I think in the following months, one of the brand will be introducing this guidelines to and to publish, so we can use. It's not just in for limited brand, but also for all of our supply chain. I think that's our idea, to secure the technology, the availability of the highest clean heat, and then the clean heat source, and then the ensure the sustainability. That's because if we want to have to move from coal as soon as possible. Yeah.
Thank you so much for that answer. I think we'd also love to have a copy of that particular guideline, because I think like every one of us is really would like to know what is actually being considered as sustainable biomass, right? And yeah, I'm looking forward to also receiving a copy of that one, so that we can also use as reference later on. And yeah, I think I also have some from your answer. I also have some additional questions in mind, actually. Like since feedstocks is also a concern in your facilities, do you have any particular business model or any particular mechanism that would actually ensure the availability of biomass if you need to, or how if I'm a facility who would like to have biomass boilers, how can I actually ensure that heat will be available if I need it? Because of course we would want to have a reliable operations, right? So yeah, what do you usually do on this one?
Okay, I think yes, we have some work about, but I'm sorry I cannot disclose because it's still our proprietary. This is our initiative that we cannot share at the moment. So basically, we have that idea, how to ensure the availability and so the sustainability at the same time of the biomass.
Yeah, too bad we weren't able to. Because I think everyone would really want to know that. Yeah, perhaps final question from me, if it's okay. For how about other technologies like heat pumps or solar heaters? We also have some good discussions before from team, and yeah, we've also seen that it could also be a good options for food industries. What are your views on the incorporations of solar and heat pumps in your facilities?
Okay, yeah, for the heat pump, we don't have any experience yet in our supply chains. Maybe it can be used in for the cooling purpose, like in some of the factory, tier 2 factory, we have spinning and weaving. knitting is because they usually have HVAC system that mostly from you they use in either previously they using electricity. Now they can use the absorption chiller or else because they have the excess heat. If especially if they have a high pressure boiler, they want to they want to, because they mainly only use the low pressure for the process. The high pressure one can be used for expansion for the absorption chiller. I think that's one. But I haven't seen it in my supply chain. I have seen it in my previous experience, but not in this brand supply chain. Regarding the solar water heater, is that as far as I know, I only have one site or maybe two in China, but I don't know. Yeah, what I did know is one in Vietnam. I think a leather company use that solar water heater. I think this is one. Uh, there is a climate action training that it is shared to for our for fashion industry. They also give that best case study as one of best practice. But the thing is, the as like what from the solar wiki mentioned is that it's mainly used for the preheating purposes. In some of our in some of our, not some, maybe almost all of our supply chain textile industry, it is already conducted not by solar water heater but by economizer. Such as it's kind of a waste heat utilization. You have the heat flue gas from the boiler of the heat or the oil heater in the textile factory. Those flue gas, usually 300, 400, it can be utilized to heat up the boiler feed water from 30, 40 degrees Celsius into 70 to 80 degrees Celsius. I think this is already done for most of our textile industry in a waste heat. Yeah, solar water heater maybe not yet, but I think in a way waste heat is already done. And I saw in some of our supply chain even like the from dyeing water from dyeing 70 degree 80 degrees Celsius before they go to the wastewater treatment, in which they need to be in 50s degrees Celsius. They use the they use the spiral heat pipe and like heat exchanger to heat up the feed water usually in 30 to 40 degrees Celsius using the waste heat from the wastewater from 70 degree to 50 degrees Celsius. I think this is already utilized in mostly in our supply chain. But again, we need more advanced solution because like in textile industry, we use a lot of heat. But the thing is, the heat that we use is mostly more than 100 degrees Celsius. So that's we need more innovative solution, another type of heat pump maybe that not just able to heat the water, but also heat up to 80 degrees Celsius, but also maybe heat process liquid or process or air in more than 100 degrees Celsius. And I think it's already there in Europe and in US, but maybe not happen in here in Indonesia yet, in Southeast Asia yet. I think that's it, Alni.
Yeah, thank you, Pa. And I think
Yeah.
given that, I would also like to ask now Teen, what are your thoughts on these technologies? Do you think do Solar BK already have this kind of technologies, or how, what do you think is the timeline that we can actually have those kind of technologies in the region? Yeah, do you have any thoughts on that?
Yeah, so I think for us, you know, regarding to the heating technology actually is a general technology. So everybody apply the same. We are trying to apply our technology here is for the monitoring to maximize the availability of the water heating, of the solar water heating, maximize and maximize the availability of the system, maximize the performance. But I mean that the the state of the art of technology that make the efficiency to be a significant change. I think in Vietnam is not really applicable now. I think one of the reason that solar water heating or thermal or heat pump is not very popular in the industrial scales, in the big scale, that electricity and fuel cost in Vietnam is quite cheap now. So perhaps I heard that energy cost is increasing, and I think that in case next 1 or 2 year when energy cost is higher, the efficiency of the investment is higher, I think it's much be popular. Yeah.
Yeah, just I think this is also relating to this to the questions addressed to you earlier, just for the idea of the audience, like how big is actually the capacity of heat pump that the solar PK was able to install in the past, like what is also like the range of temperature and pressures that your current technology can deliver.
Yeah, for the biggest project we do, we have been done is 76 cubic meter and 76 cubic meter per day, cubic meter per day for the hot water, and the maximum temperature is 80 degrees C. And the pressure actually is depend on the client demand, because we have the tank, and we pressurize the water as much as we want.
Yeah. Yeah, thank you on that. Yeah, unfortunately, I was already we are already like short of time. Let me check. Yeah. So yeah, I think we have like one last question we have time for one last question in the audience. I would like just to ask this I think this is more applicable to yeah, I think we can just address this later on. But yeah, since we are short of time, I just want to ask our panel any like final remarks or like departing thoughts that you would want to share our audience. Like, can we start perhaps with Mamaru for Is Mamaru still here?
Yeah, Miss Ali, actually there's a question for sugarcane, one more, but I think there's no more time. But if ever in the Philippines, actually because of the huge contribution of sugarcane in the Philippines, not just for sugar production, for power and everything, and we are helping the farmers in the Philippines. So we need really to support the industry and other biomass resources in the Philippines, because the Philippines is an agricultural country, and I believe that biomass resources will contribute really to decarbonization. So sometimes it's very discouraging that we need to focus to some other aspects of decarbonization, but then for me, we really need to support our own local resources, especially our agricultural crops, which are mainly has huge contribution actually to decarbonization efforts of the country. So I'll take a few minutes for this question on about the use of bagasse from sugarcane. So I'd like to share that in the Philippines, because our problem is sustainability of the supply of sugarcane. If there are investors who wanted to produce bioethanol or power from sugarcane, I think more on bioplastics. For example, we need to scout for sugar mills which has excess bagasse, because the generation of biomass power in the Philippines, you are required, if you are selling to the grid, you are required a 1-year assurance of supply of power to the grid. So therefore, some sugar mills are producing power, they are buying also from other sugar mills with excess bagasse. So therefore, other raw materials or other products from bagasse should be taken into account on the part of feasibility study, if there are really available feedstock supply for that particular aspect. For bioethanol, we need a dedicated area if they wanted to use sugarcane or for bagas, I think the second generation bagas for bioethanol production in the Philippines is quite costly. So I think it's not a consideration at this point in time. Thank you.
Well said, Mamaru. Can we also get some final remarks from Mr. Suresh, perhaps?
Yeah, thank you. Thanks for giving opportunity to us. So if any kind of waste heat is available, any type at any temperature, so we are there to provide the solution. So for heating and cooling requirement, so that's it. Uh, Thank you once again for giving this opportunity. Yeah.
Thank you so much, Mr. Suresh, for joining us. How about Pa Ananto? Do you have any final message for our audience?
Okay. Okay. Thank you. For me, I think I would like to extend my gratitude to CIA. Again, clean energy is not just about electricity. Clean energy is also about heat as well. In some industry, the majority of energy came from the heat. So I would like this is not just the end. Maybe it's just the beginning of beginning. So we can maximize the use of clean heat in supply chains or in the industry. Thank you.
And Tin, any final message to our audience?
Yeah. So I just that energy efficiency and the saving the long milestone, and I know that currently the solar heating or the heat pump, the efficiency in terms of economic efficiency is not really big, but we can do the very small step first, and together we can do the big one later.
Thank you, Tin. So yeah, definitely we had a very rich and engaging discussion today, and I definitely would like to thank our esteemed panelists for your time and for your expertise. We've really learned a lot, and I'd also like to express my appreciation to the audience for your active participation. I know we weren't able to cover all of your questions in the chat box, but the team promised to answer them offline and give you responses on your question. So yeah, I think from my side, I would just like to say that the journey towards the clean heat in the region actually is something that involves us all, and the collective effort from each of us definitely counts. And yeah, I hope that we'll continue this conversations, we continue sharing knowledge of best practices, and we also work together to create a world where clean heat is not only accessible but also beneficial for everyone. So yeah, I guess I'll hand the floor back to Ivan. And yeah, thank you all for being part of today's discussion, and I wish you all a wonderful day ahead.
Thank you so much. Very well said, Alni. And thank you to our panelists as well for sharing their expertise and their knowledge. So now we are at the last portion of our program, which is the wrap up and next steps. And I would like to call on my colleague also, Mr. Rezki Singh, Senior Climate and Energy Analyst for WRI and the Energy Finance Working Group Lead for the CEIA, to moderate and lead this wrap up and next step session. Rezki?
Yeah, thank you very much, Ivan, for the moderations. Thank you very much also for the esteemed panelists for the very interesting informations and active participation from our participants. So this is the last sessions. I know this is the last session. It's very close to the lunch time. However, these sessions act as a closure and also as a way for us CEIA to understand the challenges better and to capture the solution from your side. So I hope you can stay a bit for this interaction session, which is the feedbacks and inputs. So is the screen visible, Ivan?
Yes, we can see it,
I hope so. All right. So thank you very much. So we are going to use the platform. It's going to be very interactive using this platform. So I invite all the participants to open your smartphones or your other laptops or open your Google Chrome. Just get into www.menti.com and enter the code 17617185. Or for simplicity, you can scan the QR code on the right-hand side. So I'm waiting for a couple of minutes to capture to wait for more participants. We have at least now 60 plus participants. So I'm hoping like 25 to 30% can quickly join the sessions. Yeah, just open your smartphone, or you can use your smartphone. That doesn't have to be a laptop. Just enter www.menti.com and just put in the code 17617185. So yes, some participants are coming, definitely. All right, we're waiting for another 1 minute, maybe. The more the merrier, of course, Ivan. So while waiting for some participants come in, I will just want to highlight some 3 points that we can learn from these discussions. The first one is like echoing what Mas Nanto had said before. Energy is not only power or electricity, but energy is the overall final consumption we use, whether it is a fuel, heat, or also the power. And at least for Southeast Asia, clean heat constitutes a very significant percentage in the final consumptions. Therefore, decarbonizing the clean heat is one way to go when we have to achieve the net zero by mid-century. That's the first one. The second one, there are a huge developments, huge attentions coming to the biomass, because now everywhere in Vietnam, Indonesia, and also the Philippines, biomass has been deployed. But there is a huge question whether the first one, whether it is sustainable, and the second one, what is the price? How a large quantity of biomass can be attained? So therefore, when we deploy the biomass, we highlight that the biomass needs to be sustainable. We don't want to cut the forest to provide the biomass material for our heat. Therefore, sustainability, resiliency, and also security of supply are important. Therefore, traceability of biomass feedstock is the first step, then sustainability. And to achieve this, collaborations between private sectors, most importantly, the government needs to be undertaken, because without the very incentivized regulatory situations, then the traceability of biomass cannot be achieved. That's the second one. And the third one, there are plethora of other technology developments to fulfill for the clean heat, of course. Biomass is not the only one. There is a very interesting questions in the chat box, whether or not biomass can replace the coal. The immediate answer is cannot. Coal cannot be solely replaced by the biomass, but there are plethora of other technologies like solar thermal energy storage to store the energy produced during the daytime and then used in the nighttime for solar thermal. Heat pumps, whether heat pumps utilizing the waste heat or heat pumps using the air or ground source, it means the heat pumps can also use for renewable heat generation. So one thing that we need to hit regarding to the technology is technology cannot be cheap without the deployment. Therefore, again, we have to try out new technologies, we have to support new technologies, and most importantly, if we want to achieve net zero, coal need to be more expensive than new technology. Therefore, one way to achieve this internalization of externalities of coal is through carbon pricing. With carbon pricing, more technologies can be deployed in the market, and there is no perceptions that coal is cheaper, because coal is cheap now because it hasn't incorporated all the externalities. These three key takeaways sum up all the session we have today. So let's go into the survey. So we have some people on the Menti already. So here is, so all answer remains anonymous. However, we still need some country-specific information regarding to the challenges and solutions. Therefore, please include V, I, and P stands for Vietnam, Indonesia, and Philippines in your short answer, so we can acknowledge that it's coming from either Philippines, Indonesia, or Vietnam without disclosing your names or industries. All right. Okay. Okay. I want to highlight this energy balance and want to acknowledge that for Indonesians, biomass is not yet here. Not because biomass is not used or not utilized or not deployed, but because of the absence of data. Because data for Indonesia for biomass consumption is not granular, so we cannot really disaggregate the data into different sectors. And it is one of the challenges in Indonesia, for specifically because without a proper data, it's impossible to know the traceability of biomass feedstock data. And here's the first one, already answered. Most of the companies come from 25% to 75% energy consumption from heat. It means that this session, Ivan, is very timely because we are now tackling about the heat. So we can go next. All right, current technology implemented: biomass, fossil fuels, economizer for waste heat recovery, heat exchanger for waste heat recovery, a bit of electric boiler here. We believe that for Indonesia and Vietnam, where electricity price is not that expensive, electric boiler might compete. Although from our initial calculations, the price for electricity boilers, heat generated marginal cost is around 2 to 5 times more expensive than coal and biomass. Therefore, it is something that we need to elaborate more in the next opportunities. Now, again, there are many potential clean heat technologies and renewable sources available. So the question is, now, what is the percentage of your heat, 100% of your heat consumptions coming from clean heat? And unfortunately, majority still below 25%. And we have one, which is still using the fossil fuel, which is not surprising because the options are now very limited for clean heat. But if the question is, what is the most suited clean heat technologies? Now, non-surprisingly, the biomass still comes first, because biomass marginal cost is cheaper, or now, depending on the sources, it is cheaper or at par with coal. But again, we have to ensure the sustainability and to ensure that to achieve net zero in clean heat, more technological deployment need to be done, not only biomass, but also clean heat from solar thermal, biofuel, electric boilers. And some companies are having a strict regulations that they don't want to go into biomass, but they want to explore more about through electric boilers. Either it is resistive heating or electromagnetic heating, so we can achieve high technologies, high temperature. The main barriers, I can see a lot of dollar signs flowing around because economic challenges, investment costs, capital investment, economical drivers. Fossil fuel is still cheap, and carbon tax, if it exists, still relatively cheap. For Indonesia, we don't have the carbon tax at the moment, so fossil fuel is definitely cheaper. what we know, but we know that we have to include these externalities into the price. And criteria, it's also important. So we have already like curated 5 criteria. The first one is the lowest total system cost. So we are talking about both capital and also operational costs. So the total system cost is the lowest. The second one is availability of financing, especially commercial financing, not cheap money from grant or concessional. The third one is scalability, maturity, reliability. It means the technology needs to be scalable. If you need 1 ton per hour, you have the technologies, or even if you need 10 ton per hour of steam, you have the technology. It means it is scalable. It's going to be mature and reliable. It means that you can rely on the technology, not like today when biomass is very scarce and not really reliable in terms of supply of feedstock. The fourth one is innovative technologies, and the last one is largest abatement potential. It is quite surprising because from our previous experience, the lowest total system cost always comes first. But in these stations, from at least 30% of the whole participants, scalability, maturity, and reliability of technology is the most important criteria for clean heat technologies. And of course, to achieve this scalability, maturity, and reliability, more technological deployment need to be deployed first, because with the deployment, the cost will not be cheaper and the lesson learned cannot be achieved. It means that the reliability and maturity of this technology cannot be tested. All right, so comes to our knowledge product. We know that it is the first step into a huge homework to tackle the clean heat decarbonizations in Southeast Asia, but we are still committed to assist the corporates in Southeast Asia, assist them with the decarbonization journey. So how can we improve the knowledge products better? It's very important to have sharing sessions, of course, and more case studies and create FGDs. It's something that we take into account for the next knowledge product, of course. So yeah, thank you very much for the inputs. Of course, we are going to incorporate all the inputs regarding to the more case studies and success story, because theoretical analysis has been out there a lot. So we need more success story and very practical case studies to be shared among companies within Southeast Asia. All right, and lastly, if we want to highlight some subtopics in the clean heat sphere, what are the most important subtopics from your side? And thankfully, waste heat recovery can come first, at least from current participants. We will take into account this waste heat recovery because many technologies available, heat pumps, economizers, organic Rankine cycles, are available at the moment, but not yet fully implemented. So we are also thankful we have Solar BK here and also Thermax, who are the experts in waste heat recovery. We will ensure that these subtopics will be incorporated and become the priority from CEIA to be explored in the future. All right. I hope that I don't I don't spend too much time, but thank you very much for your active participations in the CEIA regional capacity building event. Do not hesitate to contact the in-person, in-country personnel of CEIA from Indonesia. There are a lot of people can be reached out, Vietnam and also Philippines. Thank you very much for the participations, for this sharing knowledge from the panelists. Also, I'm guessing that I will hand over to Ivan to close the session. Thank you very much.
All right, thank you, Reski, for that very interactive wrap up and next steps. And yeah, as Reski mentioned, we will be taking note of those insights, very pretty interesting insights, not just from the panelists, but as well from the attendees as well. And those are duly noted, and we will strive hard to keep those activities and knowledge products coming in. And yeah, and as seen in this activity, 2 hours is just not enough to really cover the topic on clean heat. There's still more to uncover. There's still more to unwrap in this field. So we really thank everyone for taking the time to be with us this morning and for extending your time to participate in this event. And we truly appreciate your presence here today. So again, I've sent the website of the CEIA into the chat box, where you can also check out other resources aside from Clean Heat, and you can also find there the email address where you can also send any questions, any comments to the CEIA team. We would also like to inform everyone that after this event, we will be preparing a key takeaways document where we can send it to the participants so that you can also see the highlights and on the major points of discussion all throughout this 2 hour FGD. Again, thank you so much, everyone, for being here this morning, and we hope you have a good rest of your day. Thank you, and stay safe and healthy. Thank you, everyone.
Thank you very much, everyone. Have a nice day. Bye bye.
Have a nice